Alright amigos, welcome back to another video. In today's video, we're going to learn how to calculate box fill for a 4 square. For this example I have here, it's going to be a good visual for us to account for the conductors and whatever else is in this box to make sure that we are within the volume stipulated in the National Electrical Code. The National Electrical Code table 314.16a, which is metal boxes, stipulates the standard sizes of boxes that there is in the trade. So for example, this is a 4 square box. This 4 square box is 4 inches by 4 inches by 1.5 inches depth. So because we know this, we can go into this table and get its volume, which is there, which is 21 inches cubed. And you will find this for anything that's standard. So metal boxes. Plastic boxes like these ones are not standard because they come in different forms and different volumes. So these are required by code to have their volume stipulated or printed inside of here. So these have their volume engraved, whereas these don't. All right. So now that we know where we can find our volume for our boxes, and we have our volume now, which is 21 inches cubed. We also looking at this example, we also have a 1/2 inch mud ring, a 1/2 inch rise. So this gives us extra volume. So we have to account for these. These also have their volume engraved on them. For example, it's right here, but sometimes they're hard to tell, or they're not engraved right or stamped right. So what you can do, what I did was look up this brand Steel City and put it in the description, and you can find the volume on the website, and that's what I did. I found it and it's a 3 inch cube. So the total volume for this example is 24 inches cubed. So that's how much volume we have to work with for this example. Now table 314.16b stipulates the volume per conductor. So every conductor takes up a certain, or is required a certain volume within the box of free space. That means that because this is 12 gauge wire, this requires 2.25 inches cubed of free space within the box. So that's how much it needs per conductor. So in a conductor or wire is, as it's stated also in the code, is every wire that enters the box is accounted for. So for example, we have 2 Romex cables coming in, but each one has 3 wires, a ground, a neutral, and a hot. So we have thus times 2. So now moving forward here, we can go ahead and count the wires. As I mentioned, the ground wire, there's 2 ground wires entering the box, but in the code under 314.16b1 through b5 box fill calculation, it states certain requirements that how to account for certain wires, or what not to account for, or how to account for a receptacle as well. That being said, we know we have 2 ground wires entering the box, but because of the code, it says that we can count 1 wire for up to 4 ground wires entering the box. So even though we have 2 here, we only need to account for 1. We also have pigtails that go from this ground joint here to the receptacle, and we also have another bare wire that grounds this box, but these are not accounted for either. So pigtails are not accounted for. That's because they do not enter the box as it's stipulated in the code. And then we also have neutral wires. We have two neutral wires that come into the box, so we account for those. And we have 2 hot wires that come into the box, which we also account for those. But again, we do not account for the pigtails that are attached to the receptacle. Now that we also have a receptacle, the receptacle is accounted for 2 times the largest wire that's in the box. So that's the volume, 2 times the largest wire. So that means it'll be 2 times the 12 gauge wire we have here. So let's start counting how many wires we actually have so we can do our math. So since we said we only account for 1 ground wire, we account for 1, and we know that it's the volume is 2.25. So 1 times 2.25. We have 2 neutral wires times 2.25. We have 2 hot wires times 2.25. And let me get another. And then we have a receptacle, which is 2 times the largest wire volume that it's taking up. So receptacle accounts for 2 times 2.25. Now that we have this, we can we'll start counting our. So what I like to do is I like to put my equal sign. So we have 2.25 equals 2 times 2.25 is 4.5. Again, another 4.5, and again another 4.5. And now I'm going to add these up. All this is going to give me my total volume. So here we have 6.75, and this is all inches cubed, and this is going to be 9. You could put 0 if you would like, inches cubed. So now we do our final addition. So we add this, so 15.75 inches cubed. So this is the total volume. This is the total volume that this 2 wires, the receptacle, and wire nuts and pigtails, because we don't account for wire nuts or pigtails. This is the total volume that we account for, 15.75. And our original volume that we have total that we can use with our 4 square and mud ring is 24 inches, meaning 15.75 inches cubed is less than 24 inches cubed. So we have plenty of space here for this setup. And you might wonder, well, why care so much about the volume that's available for the wires and receptacles inside a box? Well, the whole purpose of this is to protect the wire. We want to protect the wire by protecting the insulation, because we don't want to have everything jammed in there, which can potentially damage the insulation. And that's the whole purpose of this. We want to protect our insulation. And now that we know and we've proven that we have enough volume, we can say this is a good setup. And we have room for maybe even having wire passing through here to another. This could be a junction for another circuit, but we don't. It's better to have more space than less available. And I'm going to list all this information also in the description. I'm going to list all this from the code, the tables, and the box fill calculations, because this tells you exactly what to account for, how to account for it, and obviously make sure that you have a good box fill. Well, thank you, and this is all there is to it. Maybe if you want another example with a different kind of setup, more wires, or a blue box, or 41116 box, or multiple receptacles, let me know, and I can do another calculation, and hopefully it'll work as well. All right, well, you guys have a good one.